So we can start our second part of today's virtual roundtable. And we have now three presentations about case studies conducted during the quality of life project. And would start with the Netherlands case study and with Maarten Kroesen from Technical University of Delft. Maarten, are you here?
Yes, I'm here, Ingmar.
Yes.
Okay, thank you very much for being able to present here our work we did on this project. It's always nice to share the results. So next slide, please. So I performed a case study for the Netherlands, and what we actually did was to compare the territorial quality of life framework that we developed, and we compared it to existing approaches to measure quality of life within the specific case studies. And for the Netherlands, we also looked at or performed analysis as how population density and the aging and decline of the population affected the various dimensions of quality of life. So it has a more empirical analytical orientation. So just to introduce this case, the Netherlands, it's a relatively small country in Europe, but very densely populated. So 17 million people residing in an area of 33,000 square kilometers. So the most dense regions are the Randstad region on the west side. I see the red areas on top, Amsterdam and Rotterdam. And so the other regions are less densely populated. Next slide, please. So a specific challenge in terms of quality of life in the Netherlands is that we have, of course, these densely populated areas. Of course, for that, it's interesting to see how that affects quality of life. But also in several areas in the Netherlands, we have decline of population, and also those areas are highly correlated with aging populations. So especially in the northeastern parts, southeastern and southwestern parts of the Netherlands, you have this problem of declining population levels and aging populations. And so therefore it was an interesting case study to look at how those trends affect quality of life in terms of the measurements that were there. So for this analysis, we also used kind of a novel statistical technique, namely latent class analysis, to discover the various clusters of quality of life, so various quality of life profiles, which provide a more contextualized understanding of quality of life in a particular region. But I'll come to that. Next slide, please. So in the Netherlands, there have been three previous attempts to define and measure quality of life. So we reviewed these in the report, and then we compared the approaches with what we developed in the project. So we have the Regional Quality of Life Index, which was a study conducted in 2014 by the Central Planning Agency in the Netherlands. We have the Living Barometer, which is actually very firmly grounded in policy, because it's also used to select neighborhoods for quality of life enhancement programs. So it's very well embedded in policy. And then we have this sustainability balance instrument, which is developed by several municipalities in the Netherlands and also used to measure quality of life. Next slide, please. So this Regional Quality of Living Index was a one-time effort to measure and define quality of life. It's loosely based on the 8+1 framework of quality of life developed by Eurostat. So based on 9 dimensions and 25 indicators, which were objective and subjective in nature, they developed this overall quality of life index, and they measured quality of life using the index for all NUTS 2 regions. and came up with this picture. So some specific recommendations were formulated, but there was no follow-up in policy actually. So it was a standalone effort to measure quality of life. Next slide, please. So the second one is the living barometer, as they call it. So it's not very strongly theoretically grounded. Basically, indicator selection proceeds mostly on practical reasons. The availability of data is actually leading. So you do use quite a lot of indicators, 100 objective indicators, so no subjective ones. And they cover these 5 domains of housing, physical environment, services, residence, and safety. So it's interesting to see actually that this index is most strongly embedded in policy. So neighborhoods that perform low on this scale are actually selected for policy programs. But even though it's most strongly embedded in policy, it's not most theoretically motivated. So indicator selection is very arbitrary and just driven by data availability actually. And the nice thing about this measure is that it's has a high spatial resolution. So you can see really at the level of neighborhoods. So here you see the picture of Amsterdam. So also particular neighborhoods that score low. And this also relates to the ecological fallacy problem hinted by Carlo, is that if you aggregate quality of life at bigger regions, these differences are averaged out. And the nice thing about this high resolution is that you can really see those neighborhoods that perform poorly on this index. Next slide, please. So the third effort to measure quality of life is based on this index. They call it the Sustainability Balance Instrument. So it's based on 3 pillars related to ecological, social, cultural, and economic dimensions. Also quite a lot of indicators, 90 in total. And again, it's a mix of subjective and objective indicators. And it's a bit higher level of aggregation, so it's at the Lao2 level. And so you get these pictures. And you see, there's some correlation between the 3 indicators, but they do measure different things. So again, this index is quite theoretically grounded, and then you see also that the data it's much more difficult to get the data. Next slide, please. So what we did is, we basically compared the developed framework with these 3 existing indices and looked at overlap and also gaps. So what we kind of found out is that our territorial quality of life index is quite strongly theoretically grounded, and so it covers most of the aspects that have been included in these previous attempts, and more actually. So some dimensions, digital connectivity and factors related to work and public spaces were not included in these previous indices, and they are included in the territorial quality of life framework. But the general takeaway is that the territorial quality of life framework is quite strongly theoretically grounded. And that also means that it puts pressure on the data availability, because you want, especially related to the life flourishing dimension, you want to have indicators that adequately represent that dimension, and it's quite difficult to find data related to it. So there you see the trade-off between data availability and the theoretical support behind the measurement. Next slide, please. So as I mentioned, the focus was also on assessing how population density and also aging of the population affected the various dimensions of quality of life. For that, we did a latent class analysis. So we used here the data of the Sustainability Balance Instrument because it was also quite strongly theoretically grounded. We basically performed this cluster analysis at the level of municipalities in the Netherlands. So it's 355 municipalities. We came up with this solution. So 5 clusters were revealed that have particular quality of life profiles, as you can see. So for example, the first class contains 50% more or less of the sample, and that profile more or less reflects the sample average. So that's the last column. So these are indicated in the figure with the beige color. So they occur more often and are spread across the country. So the second cluster actually performs above average on all indicators. So that's class 2. Those are the green areas in the Netherlands. And then the third cluster is quite low quality of life on all 3 dimensions. And so these are typical patterns you would expect. So these 3 dimensions, they also correlate among each other. But then you see the final 2 patterns, they provide distinct pictures of quality of life in these regions. So for the fourth cluster, it performs most poorly relatively on the ecological dimension. So you see these clusters are actually the larger cities. Regions with populations of 100,000 to 200,000. So you see here those larger regions, they indeed perform poorly on this ecological dimension. And then the fifth cluster is most interesting because those are mainly the shrinkage regions, so to say, so where the population actually declines. And there you see that it puts most pressure on the economic dimension. So the ecological dimension is actually quite good for these regions, but in terms of job availability, those kinds of things, these regions perform really poorly. So the nice thing about this cluster analysis is that it provides distinct profiles, and you can also see that different profiles underlie similar overall quality of life scores. So it helps to identify the underlying reasons for low quality of life in particular regions. Next slide, please. So we also applied this clustering methodology to the NUTS 3 level at European level. And there also you can see distinct clusters, distinct profiles that reflect different quality of life. So here we found 6 clusters using the 3 main dimensions of the territorial quality of life framework. So the good life enablers, life maintenance, and life flourishing dimension. And what we did here also is in the second last row of this table, we included subjective quality of life using measurements from the European Quality of Life Survey. So these are just scores by people who have participated in these surveys. And then you can see how our dimensions actually correlate also with this subjective experience. So here it's also nice to see what kind of different clusters are there. So the first cluster is again a pattern which more or less reflects the sample average. So you can say it's average quality of life. So it's not very surprising, as 30%. The second cluster then performs quite well in terms of life enablers and life maintenance, but actually quite poorly or relatively poorly on the life flourishing dimension. Still, both clusters have a high subjective quality of life. Then the third cluster actually performs quite well on life flourishing, but poorer relatively on the life enablers and life maintenance dimensions. So you can see also in the figure which clusters are those. It's in Poland, in Spain, and Greece. So the fourth cluster, it's 9% of the sample there, especially the life flourishing dimension is low. And then the fifth and sixth are basically the poorest scoring clusters. But there it's interesting to see that actually the fifth cluster performs poorest on all 3 dimensions, but the subjective quality of life as rated by people living in these areas is actually higher than in the sixth cluster. So even though the objective conditions are poorer in these regions, people's scores are higher than in the sixth cluster, where the objective conditions are quite good or relatively good still, but people score their quality of life as less. So Next slide, please. That's the conclusion. So I think it's, for us, it was interesting to see this trade-off between, okay, you can develop a very theoretically grounded quality of life index, but that puts pressure on data availability. And that's also what we saw in the Netherlands. The one that is most embedded in policy is actually not very theoretically supported. And we saw in the Netherlands how the different dimensions, population size and aging and population decline affect the quality of life dimensions. And the latent class analysis was found to be a suitable technique to discover these quality of life patterns. So that's it. Thank you for your attention.